Welcome guys. In this lecture we'll be talking about Newton's laws of motion. So most of you must be knowing that the laws of motion all deal with force, acceleration and all that. So the most important thing while learning this is we have to know the notion of force. Okay, so we have to know what force is, how is it applied, and how force can be toggled and not toggled. Force can be balanced, force can be unbalanced, like that. So let me open up Paint real quick. So here just imagine this is a block. This is a block, okay, and someone is pushing the block like this. So what happens, this block starts to move in this direction. So we just imagine a person with force F is pushing the block in this direction. So it will be moving, it will be in motion in this direction. Fine. So what we can say that force is nothing but a push or a pull. So what we can do is another thing, if the person is standing here and he's pulling this box towards him, or the person is standing here and giving the box a push in that direction. So whatever it happens that we make this box in motion. So force is something that causes motion. Now just imagine this is a carom board. Okay, just imagine this is a carom board, and this is a striker of the carom board. So what happens is that after we give a strike like this, if we put a strike here, so the striker moves in this direction to up to some extent and then stops, maybe it stops here. Okay, so now we will be looking at this notion that we need force to keep the thing in motion. Is this statement true? I want you to know, I want you to tell me that, is this statement true? Do we need force to keep a thing in motion? Like, see, when we are pushing this box and when we stop pushing, the box will be at rest. So do we need force? Do we need continuous force to make a continuous motion? Do we need it? So our answer is actually no. Answer is no. So what happens is, now just imagine in this carom board we sprinkle some powder. Okay, we sprinkle a lot of powder. So what happens when we push this striker with the same force, it will go a little more in this direction. Maybe it goes here. So maybe it goes here. Okay, so why is there a difference in when where it goes first and after the powder it goes more far? So it happens because of a force called friction. This is actually when we magnify our carom board, it looks something like this, and our striker is something like this. It's not smooth, it's rough. So what happens is the powder molecules get between these caps and make this a smoother plane. It gets here and makes it smoother, so that the friction coefficient is reduced and the friction is less, so it goes more distance. So our simple answer to the question we asked earlier, do we need force to keep the thing in motion? The answer is no. So why do we need force? Important question, why do we need force in the first place? The answer to this particular question is we need force to keep a thing in motion is wrong. Now we need force to start the motion is right. So whenever we want anything, like just imagine this is a trolley. Just imagine this is a trolley. I don't know. Just imagine this is a trolley. So just imagine this is a trolley bus, and then when we push it in this direction, it will start moving in this direction. So after going a certain distance, it will stop. So we need it will stop because friction will be acting in this direction. So friction will be causing it to stop. So most of the things that are stopped in our day-to-day life is stopped by friction. So what we need to do is just imagine if we have a surface that is completely smooth. By completely smooth, I mean there is no friction, there is no notion of friction. So what will happen if we just apply a little bit of force, because this trolley to be in motion, then it's found that it will always be in motion, it will never come at rest. So why do we need force? A very simple answer of why we need force. The question arises, why we need force? The answer is we need force to change the state of motion. A very simple answer. So what we see here is we need this force to cause motion, and then we need force to stop motion. So what we need force is to change the state of motion in which an object is. So this is force, and this is the need of force. So now we come to the first law of motion. So you see, if the laws of motion were invented by Sir Isaac Newton. He was an English scientist and mathematician. So also he invented gravity and a lot of things. So these are the first this is the first law. An object in motion tend to remain in motion, and the object at rest tend to remain at rest unless acted upon by an unbalanced force. By unbalanced force, what do we mean? Just come here. We just create a new one. So by unbalanced force, we mean, like, just imagine two people here. This is one guy and this is another guy. So they are playing tug of war. Okay, tug of war means they are pulling this rope. Well, he is pulling in this direction and he is pulling in this direction. So if both of them stay at rest, I mean he's pulling at the same force as much as he's pulling, then what will happen? They will not be able to move this rope. Or else what will, if this guy is like strong, he's like Khali Hulk, he's like really strong, then what he'll do is, like, he will pull it so hard that this little thing will just go in his direction, he'll be accelerated in his direction. So this when both of them are equally strong, they will pull with equal force, and the force caused here will be balanced. It will be a balanced force. Okay, if there is no, if they are both stationary and they're providing with equal strength, there but if this one is Hulk, just imagine now he is Hulk, and he is someone, he's me, I don't know who he is, but he's me. Then Hulk will push, he'll pull me towards me, he will pull me towards him. So this state of motion where he is more strong, he is applying more force and I'm applying less force, this state is called as unbalanced. Here now there is unbalanced force. Okay, so now when there is unbalanced force, he will cause motion inside me. I was at rest earlier, and when he applies more force than the force I was applying, so he will cause me to be in motion, I will move towards him. Okay, so this is unbalanced force. I hope you understand what unbalanced force is. So what first law of motion tells us is, if an object is at rest, just imagine he is at rest, until and unless an external force is applied to him that will make him to go in motion, he will always be at rest. So a simple example is, just leave a cup of coffee in your table. Leave the cup of coffee in a table, and then you go to a summer vacation, come back after 3 years, 4 years, I don't know how many years, but you will just see that until and unless a burglar or a thief came to your home, that is another case, but if there is no thief or burglar, then the cup will always be in that table only, it will not move until and unless a thief or a burglar comes to your house. Okay, so what we understand from this is, if a object is at rest, it will always be at rest. Now the vice versa is also true. Now when the object is at motion, just I just told you about that carom and that other thing. Just imagine that there is a surface with no friction. Now ideally this surface is not possible, but when there is a surface with no friction, this will always keep moving. A very interesting example is that of solar system. In vacuum, there is no friction, there is no air, so there is no air friction. So what happens, our celestial bodies, just imagine this is sun. Okay, this is an orbit, this is a planet. So what happens, sun is pulling it towards him, the centripetal force. So due to centripetal force, it starts motion, it starts revolving. And now you will be imagining why this never stops. Now sun does, yeah, there is one notion that sun is always applying force to him, but there is another notion that why it requires much less energy for this to go. The very intriguing part is that once it is gone in motion, it will never stop. That's inertia. That's the law of inertia. That's Newton's first law of motion. So there was unbalanced force here. The planet started moving, and now it will always keep on moving until and unless there is some external force applied here. Another example is asteroids, meteors, and comets. Very big, very good examples are meteors and asteroids. So what happens is these asteroids move freely in the space. So once they were caused to motion due to some blast or something like that, they were set to motion, and since there is no external force there to stop that motion, they will always remain at motion until and unless they reach someone's other's gravitational field. Like this is Earth's gravitational field. Just imagine this, just in motion it comes and enters his gravitational field, and then it will just go towards Earth. That's another thing. So what I'm trying to say is that an object which is at motion will always be at motion, no matter if what, until and unless we apply an external force to stop it. Okay, this is Newton's first law of motion. So what is meant by unbalanced force? I told you the forces, like the table pushes upward towards the book, gravity pulls the book downwards. So this is just unbalanced force. What unbalanced force is: tug of war example, soccer ball sitting at rest. I just told this example is like we need to give the soccer ball a kick to make it in motion. The tug of war example I gave you. So Newton's first law of motion is also called the law of inertia. What is inertia? The inertia means the tendency of an object to resist change in its states of motion. Inertia is nothing but what we all talked about. A thing in motion tends to remain at motion. A thing in rest tends to remain at rest. I'll write it down. An object in motion tends to remain at motion, and an object at rest tends to remain at rest until and unless an external force is applied to change its state of motion. So this tendency to just keep that state of motion is called inertia. Am I clear? So what is inertia? We know, and the first law states that all objects have inertia. The more mass an object has, the more inertia it has. Like just imagine this. This is a wall. Okay. This is a wall, and this is me. I'm standing here. So I try to just push the wall with all my might. So does this wall move? Answer is no, it doesn't move. It doesn't move because I don't have enough force to cause motion. I don't have the force to overcome its inertia. Inertia is the tendency to stay at motion. Stay at the inertia is the tendency of object to retain its state of motion. Okay, so when we apply a force less than the inertia, less than what it's needed to overcome that inertia, it will always be at that position only. So also imagine this is a hill. I'm standing here. Someone just threw a huge boulder from here. It's coming towards me at full speed, at full throttle. It's coming. So what's my options here? Do I just turn back and try to stop the boulder? It will not happen. It will just crumble me. So what we have to do is I have to run. Okay, I can't stop it because its tendency is to be at motion. So my force will not be enough to overcome its inertia. That's the tendency to stay at motion. Okay, so this is what our first law says, that if an object is at motion, it will tend to remain at motion. If an object is at rest, it will tend to remain at rest. Okay, so the more mass an object has, the more inertia it has. So another very good example is that when you can just pick up a small rock and throw at someone, but you can't pick a huge boulder and throw at someone because you can't overcome its inertia. That's the reason. Okay, another very interesting example is that you have experienced this phenomena many times, I think. You are in the bus, okay, crowded bus. Just imagine you're standing here holding the thing that's there. You're holding this, and the bus is speeding. It's at full speed. Suddenly, a goat or something comes in in front of that bus, and he just puts the brake. What happens? You're moving this direction. Whenever he puts the brake, you will just fall very hard on the front. He will move there. So what happens is that this platform you are going, you are also moving, this platform is also moving. So what happens when the bus driver puts the brake, this platform suddenly comes at rest. But what happens to you? Your inertia says that I will be in motion. So your inertia, until and unless you stop yourself, your body will try to move forward with that motion. So that's why you lean forward like that. And also another thing, when in train, just wait, in trains, you see a train will always slow down very much. It will slow down before it stops. Why is it so? A train is connected like this, the bogies are connected like this. So what happens if it just suddenly stops? The engine stops, this is stopping, this is at rest, but these are still at motion. So it will take some time to overcome its inertia. So it will just collide with the other bogies and there will be a terrible accident. So trains always tend to slow down before they stop. Okay, you can't suddenly stop a train like you can a car or a bike. Also this car example, so imagine you are going in a very expensive car with no ceiling. You suddenly see a brick and you put brakes, and you are a hero, so you don't wear seat belts. You will just move out. Oops. You will just move out and be thrown outside and hit something. Always wear seatbelt, guys. More examples, the train and other things. A very interesting example is this. In outer space, when there is no gravity, just imagine a rocket is sent outside, okay? Just imagine this. From Earth's surface, a rocket is sent outside. This is a rocket. Very bad rocket, but still, it's a rocket. His rocket is sent outside. So as soon as it overcomes the Earth's gravitational field, so it will not require any other force to just stay in motion, because in open space there will be no external force to stop its motion. So that's how a rocket will just move away. So when it will have to change direction, that time it will have to need some throttle or something like that. Okay, interesting example. Now the second example, the second law, I'm sorry, the second law of motion. So what's the second law of motion? Force equals mass times acceleration. Nothing but we just have to imagine, just have to know this equation, small equation. Acceleration is a measurement of how quickly an object is changing speed. Acceleration defines velocity. Okay, this is a vector quantity. So what happens is that our this, just imagine this is a, oh sorry, uh just I'll just teach it from here. Okay, so we are saying that force is directly proportional to mass and acceleration. Just what does that mean? So if we change mass of an object, so this is a ball, just imagine this is a ball. Okay, it falls from some height like this. Okay, so when it falls, it will have the gravitational pull. So gravitation gives him an acceleration of g is equal to 10 meter per second. Just imagine it's 10 meter per second square. This is its acceleration, and this is some mass m. Okay, imagine I'm standing here. This is a small ball. Okay, a ball of like 10 grams, I think. Okay, 10 grams. It will fall on my head from like 15 meters, I think. So when it will fall on my head, it will just cause a swelling on my head and it will hurt me. Now just replace this ball by a huge ball of like 2 kgs. So when this will fall into my head, it will just thrash my head or something. It will just kill me like that. So why is this? Because the force is directly proportional to mass, and force is also directly proportional to acceleration. So what happens is, now when the mass is changed, the force increases and it will hit me with more force. Okay, just imagine now that you are standing here. Okay, let me just erase this. So now just imagine you are standing here and you throw the ball with all your might. Okay, so now what happens, this acceleration is added to the force you add here, the acceleration you cause by your force. So it will be some this plus some acceleration. So if you have a very strong arm, then it will have a very high acceleration. Just a minute. Okay, so this will have a high acceleration, and what will happen here, this ball will have much greater force and it will hit me harder. Okay, so force is directly proportional. The force will increase if mass is increased, the force will increase if acceleration is increased. Very simple thing. Okay, so this is what it said here. Just we make the ball twice as big, then the force will just become twice the actual force. That's the same thing it's talked about here. Also, a very interesting thing is that a very huge thing, but which is moving very slowly, can still have a very high force. Like a glacier, it moves very very slowly, but it has very less acceleration, but it still can have a very great force while it comes towards you. Avalanche or something like that. But also a thing with very small mass, a thing with very small mass that's moving very very quickly. Okay, a thing with small mass which moves very very quickly, and it's like a bullet, and then it will have a great force. Something with it will have a very very great force, and now a small thing with very small acceleration will have very very small force. I'll just tell you a very interesting thing. Like now, pay attention while you look at this. Just imagine our earth. This is our earth, and from outer space there is a needle. You all know what a needle is. Okay, a very bad needle, I think. No, not this needle. Just imagine this is a needle, and now this needle is traveling at a speed of light. That is, this needle is traveling at the speed of light. Just imagine 3 into 10 to the power 8 meter per second. So this is the absolute highest speed a thing can achieve. Okay, so this needle is traveling at the speed of light and it's approaching towards earth. So now my question to you is, what would happen? What shall happen when this needle traveling at the speed of light will hit earth? I really want you to go down to the comment section and write it right now what you think should happen. Then I'll tell you later about this. Okay, at the end of the video. Interesting topic. I'll tell that later. Okay. So now we move on to the third law. Now, third law is very important, and it's very simple also. For every action, there is an equal and opposite reaction. Very simple statement. So what happens is that whenever you apply force at something, that the thing you are applying force also applies the same force towards you. Very simple thing. So there is nothing much to talk about it, but there is one thing I would like to tell you. Uh, you might have just done this a lot of times when the people would have taught you about this. You go towards your friend. Here's your friend. You slap him in his head, and when he tries to beat you, you tell him that I slapped you, I applied force, your head also applied the same force, I also felt the same pain. You say like this, but it doesn't happen. Actually, you felt less pain and he felt for more pain. So why is this happening? So why is this happening is because when you hit someone, you hit, your hand is in motion. Okay, your hand has a certain thing called momentum. Okay, this is there is momentum, and that is equal to mass multiplied by velocity. So when you hit him, your momentum is higher than what his head's momentum is. His head is at rest, so his momentum is 0. So when you hit him, your momentum is higher, so the energy transformation. So now many of you might not know this, but the actual formula for energy is, or kinetic energy is nothing but momentum is denoted by p into the velocity. Okay, this is what kinetic energy is. So the oh sorry, half of it's half of momentum into velocity. Okay, it's half of this. Can I correct this? I'll just delete it and write it properly. Kinetic energy is equal to half of momentum into velocity. A very simple thing. So when you're hitting the other guy, your kinetic energy is high because your momentum is high, so you transfer more energy into him than the energy he transfers into you. So that is why he feels more pain than what you feel. Okay, so this is our third law of motion, that everything you hit, every action has an equal and opposite reaction. For every action there is an equal and opposite reaction. Very simple. So now coming back to our question, so this is our interesting question: what shall happen? So I hope most of you might have guessed what will happen. So now I'll tell you what will happen. So when our earth, this is our earth has core, also has mantle. So you might not know that this the entire reaction of what is going to happen is already, or is going to depend upon the position of the needle. Now if the needle flying at the speed of light enters our earth's atmosphere, okay, we just imagine that there is no earth, our atmospheric layer gives no friction or air friction to this needle. If our earth's atmosphere gives air friction to this needle, it will just disintegrate in the space. But just imagining, it will not disintegrate in the space. So if anyone of you has written that it will disintegrate, it will be a very correct answer, because when it enters the atmosphere, it will just disintegrate. But when it's traveling at the speed of light, it just imagine it doesn't disintegrate, and it hits the earth's point at some point like this. Okay, now it all depends upon where it's contacting. Now if its angle is something like this, it will just move without touching the core. So it will just create a small hole and then exit from the other hole. It will not create any disturbance. But if it comes and hits the earth's core at any angle, it's at 180-degree angle. If it hits our earth's core at any angle, then our earth's core will have a very high our core's density is very high, you all know that. So whenever a thing enters and disturbs that density, it just tends to spread. And when it will tend to spread, now very important, why will it tend to spread? Now just imagine you just punch water very hard, water tends to splash out like that. When that needle will hit the earth's core, the molten magma there, it will try to expand from the highly dense point. And when it will try to expand, our core's internal temperature will be lowered. Okay, when the internal temperature is lowered, what will happen? The core will it will start to disintegrate. And disintegrate, I mean that this core will start to it will start to rock, it will start to solidify. It was in a molten state, and now it will start to solidify. And when this core starts to solidify, the entire planet will disintegrate in a matter of seconds. So if this needle strikes the core, then it will just destroy our planet in a matter of seconds. A very interesting fact if you want to know. So that's it for this video. I think I explained most of the things about Newton's laws of motion and also that other thing. So I hope you're really helped by this video, and if you're helped, drop a like, subscribe if you want, and stay tuned for more videos.